Okay, so last problem set here is about power, and power is basically the rate of energy transfer over time, or power equals work over time. And power is measured in energy per time, so that's joules per second, and this has a special name. It's called a watt. So if you think of like a light bulb's brightness is measured in watts. That's how many joules of energy that the light bulb puts off every second. So that's a power rating. So for this first problem, we are given the weight of this marine, 705 newtons. That's not a mass. Mass would be kilograms. This is mass times g. So that's weight. And we're given a delta x, right? Um, and we're given a time. These are my givens. Well, power is work over time. So that's force times delta x over t. So that power in watts is going to be that force, the weight force, Fg. These are my givens. Times delta x divided by t. So that's pretty straightforward, about as easy as it gets for a power problem. For the second one, we have an atmosphere that has all this water in the clouds. Now, that water we know a mass of. So, givens here. We know the mass of the water. We know the altitude. That would be how high that water is in the air. That would be our delta x for how high we have to lift that water. And don't forget here that that number's in kilometers, so not meters. So that should be converted to meters for this problem if you're going to standard units. And then we also know the power is given for this. Again, that's given in kilowatts, not watts. So that 2.67 kilowatts would actually be 2,670 watts. And then we're asked about time. So we would get power equals work over time. And the work here again would be equal to the force times delta x. That is the weight of this water times the delta x of it, the height, the altitude. So we would get P equals Fg, which is mg, mg delta x over t, and t equals mg delta x over the power. In this case, you'd also want to convert that time given in years, right? You convert that time into seconds, and then you're going to need to convert it back into years at the end because this power is given in kilowatts. So that's 1,000 joules per second. So if you're going to combine units here, you need to use kilograms, and G is going to be in meters per second. Delta X needs to be in meters. Power is going to give you an answer in terms of seconds that you'll have to convert back into years at the end. Again, for this next problem, we're lifting a piano at a constant speed using a pulley system, right? We're given a power of each person. So my givens, power of each person, the total power would be double that, 2 times the power for each person. We're given a gravitational weight of the piano, and we're given a delta x, a height of that piano that we have to lift it to. We're also given that this process is only partially efficient. So 75% of the energy that I give is going to get into the piano. That means I need to provide 25% more energy than it would actually take to get it up to that original height in order to account for the energy that's lost to friction here. After that, the problem actually gets pretty straightforward. So we would still have power equals work over time. That's power equals force times displacement over time. And that force is Fg. So that's power equals Fg delta x over t. My time would be Fg delta x over p, and that's p total. But remember, this is if it's 100% efficient. So my true time is going to be 25% more than that. So t in actuality is going to be 1.25 times Fg delta x over p total. Right? That's 25% longer because 25% of the energy I use is being lost. So there would be my final answer. Again, remember that it's asking for this time in minutes. Our power is given in terms of watts, so that's in terms of seconds. So you'll need to convert these numbers. Kilonewtons will have to be converted to newtons, and then my time at the end will have to be converted into minutes instead of seconds. So this next problem, we have a elevator moving upward, but it's moving upward with a constant acceleration for 4.5 seconds until it reaches a cruising speed of 1.75 meters per second. Okay, so in this case, the easiest way to look at this problem might be in terms of change in energy instead of in terms of a force applied over distance. Although both of those methods will work, the simplest way might be to think of it in terms of power equals change in energy over time. Why? Because I'm already given the final velocity, right? So that makes it more simple here. So for part A here, let's say power equals change in energy over time.